explanation for this problem. In the first part, after looking at the proof wiki solution, I thought, well, first we know BC is greater than AC, so we're aiming to show that this angle is greater than this angle. And I thought they had constructed this line such that it's of equal length to AB. But then what use would that have? So if this is Y, this would be Y as well. And if we call this angle Z, well, this construction tells us that Z is greater than Y. But then Z has no discernible relation to X, angle BAC. So that doesn't really tell us anything. Furthermore, is it always possible to construct this line AD such that it's equal to AB? Well, I don't think it is, because if you think of a triangle where AB is the longest side, then it's impossible to construct a line that's equal, because this sweeps out like this, and yeah, so that's not possible. So what construction could be better? How about we try this? Construct the line AD such that AB is equal to BD. Now what does that tell us? If we call this Z, and this Y, what does that tell us? So I'll call this Z actually. Right, what does this tell us? This triangle is isosceles, so at least we're involving the whole angle in some part. So we're saying this angle here is greater than Z. So something smaller than X is greater than Z. So that tells us X is greater than Z. But then Z has no relation to Y. So I don't think this tells us much either. Furthermore, we can also ask, is it always possible to make this construction? Well, again, if AC is the longest side of the triangle, and we want to construct some line that's equal to so that this line is equal to AB. AB is the longest side, so of course we can't construct a line on a shorter side that's equal to the longest side. So this construction isn't even possible for every triangle. So we want a construction that involves this angle X somehow, either in part or in whole, and we want a construction that is always possible to make. So what do we know? We know BC is greater than AC. So this side is greater than this side. That means we can always construct a point AD such that these two sides are equal. Let me draw it so that they actually are equal. Okay. Again, because BC is greater than AC, so the length AC is somewhere along this line because it's smaller. Okay, so what does that tell us? Well, it tells us, because this angle Z is an exterior angle to ABD, that means Z is equal to Y plus this small part of X. So Z is definitely greater than Y. Well, X is equal to Z plus a little bit more. So X is greater than Z, and Z is greater than Y. So X is greater than Y. And that completes it. So the longer side subtends, the greater side subtends the greater angle. And the supposed proof I did yesterday, I tried to construct this line, and I said these two are equal, and X is an exterior angle to the lower half triangle, so that means X is greater than Y, right? Well, it's not always possible to construct this line. Yeah, there are many situations where you couldn't construct this. For example, if this was some obtuse angle, then if you think of C as a center of a circle with radius AC, then there wouldn't be another point on this side of the triangle where it has length AC. So that clears up things from yesterday.